Most of the other talks at JuliaCon are about big and important things, real game changers. Let's take a break from that and talk about something tiny and unimportant. Internet arguments. Julia is a pretty unbelievable language. It combines multiple aspects of languages that are often thought to be at odds. Dynamic typing and C-esque performance. Packages written by academics and readable syntax, you get the idea. A seasoned programmer's first reaction to all this is to look for cracks in the ship. Places where the contradiction collapses and everything makes sense again. If Julia self-evidently reads like Python, then surely it can't run as fast as C without wrapping an existing C library, right? This back and forth repeats every time someone sufficiently skeptical encounters Julia for the first time. Because I value my mental health and my sleeping habits and going outside occasionally, I don't engage with this kind of argument. Usually. A couple months back, a friend in the Julia community messaged me and asked if I'd seen the discussion on the old Orange website because someone found Julia to be quite lacking in a very particular kind of benchmark. There's a famous esoteric programming language we'll call Brain Truck, which has 8 instructions, which tell you how to manipulate a strip of memory and a pointer. Brain Truck is a minimal Turing machine and is dead simple to write an interpreter for. The benchmarks in question found Julia to be quite slow at interpreting Brain Truck instructions. Compared to other languages, it was middle of the pack at best, bringing up the rear at worst. Yikes! So why was I brought in? Roughly a year ago now, I wrote about 70 lines of Julia code that took a different approach to the same problem. Rather than interpreting code at runtime, I thought, hey, wait a second, these Brain Truck instructions just correspond to Julia expressions. I can write a macro that translates those instructions into a native Julia function and run that instead. And behold, galaxybrain.jl was born. I took this code, left mostly untouched from when I first wrote it, and tried running the same benchmark with GalaxyBrain instead. To my surprise, this change improved on the original times by a significant amount. To my delight, it also passed the fastest languages in both categories by a factor of 8 and 13 respectively. It's not necessarily interpreting the code at runtime, so I wasn't playing fair here, but that's kind of the point. Julia gives its users the tools to write parse-time translations that are faster than the runtime interpretation, several times over, and just as concise. Of course it's going to feel like cheating. But by challenging existing programming paradigms, Julia users are encouraged to write code that does the same. I'm Seth Chapman, and thanks for listening to me talk about pointless internet arguments. You can find the source code for GalaxyBrain here and contact me in these places. Thanks for watching.